All right, good afternoon, everyone. So we're going to be continuing our concept of probability today, but we're going to be looking at a slightly different chart. So yesterday we kind of did all the things with Venn diagrams. Now I understand that in class, we did not finish number 8, number 11, and number 12. So I'd actually like you guys to take a second, either here at the beginning or at the end. You can pause this video, but either here at the beginning or at the end, I actually want you to go ahead and attempt number 8, 11, and 12 and see how you guys do. When you're all done, you can go over here to week 30 and take a look at the answer key and see if you agree with those numbers. But again, nonetheless, I would like you guys to try those, consider them like your warm-up problems for today. Those ones were on paper. So if you need to grab some colored pencil, or if you want to just kind of lightly shade with your regular pencil, that's fine. But go ahead and try 8, 11, and 12. Then when you're done that, we're going to come here to our notes. Now, if you want to just watch the notes and not actually record them, that is fine. Really kind of soak in everything that's happening here. And then when you're done the video, since you don't have homework tonight, if you happen to finish early, you'd be more than welcome to, again, when the video is all done, go back into your notebooks, because right now you're probably just sitting and watching the video, but go back into your notebook and kind of fill this all in. Maybe even try it yourself, because you won't have the video up and running telling you the answers. So try it yourself. And then again, if you go under your notes key, week 31 key, you can come down here and see all the answers that we're about to talk about. So let's go ahead and talk about two-way tables. So are two-way tables any different than Venn diagrams? So first things first is to understand that Venn diagrams are a pretty basic concept in the sense that they don't really have much information in them. So consider the examples we did yesterday, math and biology. There's only really two concepts going on there. Are you taking math or are you taking biology? And that's about it. Two-way tables typically have more than one category at hand. So think of it like this. Yesterday we had math and biology. That was subject related. So what if we had math and biology, but then we had, tennis and soccer? They're totally different categories. One of them's talking about courses and one of them's talking about sports, different categories. So this first two-way table we see here is talking about boys versus girls, and then blue eyes versus brown eyes. Are there boys with blue eyes and boys with brown eyes? Yes. Are there girls with blue eyes and brown eyes? Yes. So there is a lot of overlap happening here. You have blue eyes overlapping with boys and girls. You have boys overlapping with blue eyes and brown eyes. A lot going on here. So first thing that's important in a two-way table is we want to really make sure that everything is filled in. So we're going to go ahead and fill in these totals that you guys see over here. Okay. And for the totals, we're really just going to kind of add straight up and down or side to side. So at first we can do 7 plus 9 to get 16. We could do the 12 and the 10 to get 22. Doing it the other way. Whoops. Pen works. There we go. Going this way, 7 plus 12 would give me 19. And 9 plus 10 gives me 19. The last category here is the total, and it doesn't matter whether you look this way or you look that way. It actually ends up being the same. You get 38. So again, anytime in a two-way table, the first thing you should always do is fill in all of the blanks. Okay. Then the next thing as you do is you go on to your questions. Now, the questions for two-way tables get a little bit more complicated than what we saw yesterday because you got a lot more to consider. You got to consider, are you looking at blue-eyed people? Are you looking at girls? There's a lot of aspects to consider. So let's look at the first question. The first question says, how many boys have blue eyes? So we need to find boys that have blue eyes. So the first thing you do is you kind of narrow in on the boys. So here's your boys. And then even more focused, you look at boys with blue eyes. We have 7 boys that have blue eyes. Next, they ask you, what is the probability of picking a boy with blue eyes? So again, we're saying that we have 7 boys that have blue eyes out of a total of how many? Let's pretend like these are students. Out of how many students? 38. Now, you can turn that to a percentage. I'm going to let you do that on your own time. But nonetheless, that would be your probability. Next question. How many girls have brown eyes? So same idea, go to the girls, find how many girls have brown eyes. So up here, we have 10. Okay. And we move on to question B. What's the probability of picking a girl with brown eyes? Okay, easy enough. So we would have 10 out of the total 38. Again, please make sure to turn that to a percentage on your own time. Now, question B is where it gets really interesting. I guess I should say B of B. There's two B's, but look at this question B of B. If only picking from girls, what's the probability of them having brown eyes? So this adds a small twist to it. Now, rather than looking at the entire class of 38 students, now we're saying, what if we only picked from girls? So again, we're still considering how many girls have brown eyes. We're still looking at that. So we'd still have 10, but the denominator changes. Why does the denominator change? Well, here's the thing. Up top here, we were picking girls with brown eyes from everybody, the entire class, all 38. But in this one, it says, what if we were only picking from girls? Which means now think of it almost like, putting marbles in a hat or something like that. Now my sample size, what I'm drawing from, is smaller. Now I'm only picking from girls. Well, how many girls did I have? I only had 19 girls. So if I am only picking from girls, which there's only 19 of them, 10 of those 19 have brown eyes. So the fraction kind of changes here, mainly because of that if only picking from girls. It kind of adds that stipulation beforehand. You're only picking from girls. We're not going to consider boys. We're not going to even put them in the same, hat that we're drawing from, only drawing from girls. Now we read part C. What is the probability of picking a person with brown eyes? This question, very open-ended. It doesn't say anything about boys and girls. We don't have to leave a specific category out. We're only looking for a person with brown eyes. So actually we go to the bottom of the list of brown eyes and we say, oh my gosh, we had 22 people, putting gender aside, 22 people that had brown eyes out of a total of 38 people that had 38 students in the class. Now let's zoom out a little bit here and see if I can get the next one on. Now, the next one's interesting, and there's a couple of different ways that people approach letter C here. So it says, what is the probability of picking a boy or, and the keyword there being or, someone with blue eyes? So does that mean that I need to pick a boy with blue eyes? No, it can be a boy, period, or it can be somebody with blue eyes, but it doesn't have to be both. Could it be both? Sure. But does it have to be? No. So let's actually approach this problem a little bit like we did with our Venn diagrams yesterday. So with our Venn diagrams, we colored one event, we colored the second event. And if you remember when we talked about ors, we talked about, we don't really care if there's overlap or not, we want all of it. So let's do this. Let's color in. Okay, so I'm going to go up to my chart real quick. So it says, what is the probability of picking a boy? So let's go to our boys. Here's all my boys. I have 7 here, 12 here. That's all my boys. Then let's do somebody with blue eyes. So here's my blue eye column. Here's all my people with blue eyes. Because this is an or situation, we need to take all of this. I don't care that this is only blue and this is only yellow. We want all of it, anything that we colored in. So really what we're going to want here is we're going to want the 7. We're going to want the 9. And you're going to want the 12. That should total, let's see what we get there. Let's see, 7, 9, and 12 gives me a total of 28. We do want this to be a probability, so we need that to be a fraction. Out of a total of how many students, which was 38, turn that to a percentage, and you're good to go. Now, the alternative that sometimes people, if you ever see this out and about, to me, that makes the most sense. You highlight just like we did yesterday, or you color just like we did, and you'll have your answer. There is another format that people will do, in which case they can say, okay, well, how many boys do we have? We had 16 boys in total. Actually, sorry, I read that wrong direction. Boys would be going this way. So boys, we had 19 boys. Then how many blue-eyed people? That's what I actually did first. So my blue-eyed people, I had 16, and they do this whole 19 plus 16. But the problem is when you do 19 plus 16, that gives you 35. So why am I getting 35 here, but 28 over here? And there's actually a very simple answer to this. And that is when I do the grand totals of all the boys plus all the blue-eyed people, you notice that 7 is being counted twice. I counted those 7 boys with the boy total, and I counted those 7 with the blue-eyed people. So you almost counted them twice. So we're going to subtract the 7 once. And basically what that's doing is it's saying, rather than counting it twice, I removed the duplicate. So yes, I did 19. Yes, I did 16, but I'm removing that duplicate. So is 7 still being counted? Yes. It's just not being counted twice. I removed that duplicate again. Now, when you total that, you do get 28 and you end up getting the same answer. So again, I'm fine with you doing it either way. If you want to take the grand total of 19 plus 16, just don't forget about that overlap, or you do it the color coordinated way, like we did yesterday with the Venn diagrams. And one more question, letter D. It says, what is the probability of picking a boy, and someone with blue eyes? So let's do it the same way we did yesterday. Now, maybe you just read this question and you'll have an answer, but let's do it the same way that we did yesterday. What is the probability of picking a boy? So here's all my boys. We colored that in just like yesterday. Someone with blue eyes. So here's all my blue-eyed people. And because it's an and, we want the situation where it's overlapped. And here, we kind of talked about this in the last one, there's your overlap, which means I want those 7 boys with blue eyes. That's my overlap. Now, could you have figured that out without coloring in? And you could have just been like, okay, they want to pick a boy and blue eyes. So somebody that's a boy and has blue eyes. Well, here's the 7 boys that have blue eyes. So 7 out of 38. But I think the color coordinating like we did yesterday does tend to help. So let's go ahead and move on here. So the second example that we got going here, and I would actually really appreciate it if you guys could kind of like pause the video and maybe try this on your own. But let me help you get the chart started at first before you guys try this on your own. So first thing, this chart's a little bit more tricky. So I'm going to go ahead and highlight all the blanks here so that we can clearly see everything that we're missing. These are all the values that we're missing. We need to fill them in. Now, at first glance, when you start to look at things, let's say we tried to fill this one in. And that means 16 plus this number equals that number. Well, I'm missing too much information, right? Like I don't have enough information to do all this. So when you're filling in charts, sometimes you do have to be kind of strategic with, where you're starting, what numbers can you fill in. So you start with kind of what you can do. So let's say this total right here, this would be a pretty easy one. So I have all the numbers straight up and down, 9, 16, and a 1. That should give me 26. That's awesome. Let's see what else we can figure out. We could also figure out this grand total. And you might be like, well, Miss Mara, we're missing a number here, but we're not missing any this way. So let's add them all up this way. So 26 plus 13 plus 17 should give me a grand total of 56. So again, fill in kind of what you can as you go, all right? So we filled in that one, we filled in that one. So let's see what else we got. I still don't think I can fill in these two because I'm missing too much information there. Let's see, I could probably fill in this one. Now this will be a little interesting. So this means that I need 20 plus some number plus 5 equals 56. So let's think about it more like this. Let's do 56 minus 20 minus 5. That would give me 31. That means my missing number has to be a 31. And using that logic, that idea of working backwards from the total, will actually allow us to figure out the rest of these. So let's go with this row. We have a grand total of 20. We have 9 accounted for. We have another 4 accounted for. That would give us a grand total of 7. And the last couple, I have 16, 8, and it needs to total 31. So again, 31 minus 16 minus 8 will give me a grand total of 7. And if I do that last row, this is kind of the easiest one. We have 1, 2, and it needs to total 5. That means my missing value is 2. And now that you have all of the chart filled in, you're ready to answer the questions. Now, remember what we talked about up above. Sometimes they give you that stipulation that hey, we're only looking at people that are this way, changes your denominator. So if you want to pause the video and go ahead and try to figure out the rest of these on your own, by all means. But let's look at problem A. It says, how many people with blue eyes like to play sports? So again, here's your stipulation. We are only looking at people with blue eyes. So how many people with blue eyes, they have to have blue eyes, play sports? So let's go to our blue-eyed column. So here's my blue-eyed people. These are the only people we care about. They have blue eyes. How many of those people play sports? 7. Because this is a probability, let's turn, well, I guess it doesn't really say a probability, but we're going to do a probability. I feel like somewhere in the directions it says, oh, right here. Then find the probability. So we found the amount. We have 7 people that play sports with blue eyes. But again, the question is, how many people with blue eyes play sports? So we're only looking at blue-eyed people, and we had a total of 31 of them. Now, problem B, how many people with brown eyes were there all together? So at first you're like, oh my gosh, the wording is the same, with brown eyes. But then they switch it up and they say all together. So they're just kind of giving you that generic, how many people with brown eyes were there all together? So we go to our brown-eyed people and we say, well, there's 20 people with brown eyes. 20 out of how many? They didn't really give us a stipulation. They said all people, so 56. Letter C, how many people enjoy watching TV? There is no prelude. We're not only talking about people with green eyes or things like that. We're just saying how many people in general enjoy watching TV. So we go to our watching TV column and we say, oh, there's a total of 26 people there. 26 out of how many? 56. So a lot of times you can kind of think of it like if they're talking like grand totals out of all these people, your denominator is going to be your grand total over here of 56. If they give you any of those stipulations of like how many people with blue eyes do this, that's their way of kind of saying focus on the blue eyes or the blue-eyed people. And letter D, how many people who play sports? Oh, okay, so there's kind of your stipulation. Who play sports? We're only looking at people who play sports. So let's go right up here to sports. We're only looking at these people. So how many people who play sports right here? These are all of our sports players. Have green eyes. So I need to go up here and say, oh, 2 people have green eyes in that section out of a total of 13. And there's your fraction. So again, be very careful to understand that it's saying with blue eyes. They play sport, like it gives you that stipulation of we're only looking at people who play sports. We're only looking at people with blue eyes. Okay. So again, if you have not, that takes us through our notes today. We'll practice, don't worry, we will practice two-way tables another day in class. So that's not the only day that we're seeing two-way tables, but it's our introduction to two-way tables. If you have not yet finished these Venn diagrams, please go back and do those. But that is a wrap for today.